Let's look at how a function would behave when we take the absolute value of the function or the absolute values of x. Let's take f of x shown here, for example, which is y equal to x cube plus 3, and see what would happen when we instead of x we give the absolute value of x, or take the absolute values of f of x and how the graph would change. Let's first look at the case where instead of f of x we do f of absolute value of x. What would happen to the graph? What this means is, when we put x here, if it's going to be positive, the absolute value of x is also going to be positive. For positive values of x here, the values of mod x or absolute value of x will also be positive. So there is not going to be any change. So the graph of f of x is going to be same, or the graph of f of absolute value of x is going to be the same as the original function for values of x greater than 0, which is what you see here. The graph here on the right side is same as the graph here on the right side for f of absolute value of x. But for the original function, when we have negative values of x, let's take x is minus 1 in this function, then y becomes minus 1 cube plus 3. Minus 1 cube is minus 1 plus 3, it becomes 2. So you see that this plot here is 2 for minus 1. This is minus 1 comma 2. But if we, instead of minus 1, if we put the absolute values of x, which is 1, what happens here is minus 1 also becomes 1 here. When we have x equals minus 1, that also turns as becomes 1, and that 1 is given as the input to the function. So the graph would behave exactly as you see on the right hand side. For minus 1, when x is minus 1 also, what goes into the function is actually plus 1. So when you put plus 1 into the function, it becomes 4. For minus 1 also, you get the value of y 4. So which means the graph of on the left hand side would be a reflection of the graph you see on the right hand side, and that's why you get this U-shaped curve for f of absolute value of x. Now let's see, when we take the absolute value of entire function, we give the original values of x as input, that is positive and negative values, but we take only the absolute value of the entire function. How would the graph change? What happens here, if you observe, is whenever we get a negative value for the original function, whenever f of x is going to be negative or less than 0, or the y value is going to be negative in the original function, that would also turn to positive because we take the absolute value. So for positive values of the function or positive values of y, this f of mod of absolute value of f of x will also behave exactly like the original function, which means at this point you see in the original graph, right hand side of this is all going to be same, because for all values which are positive y values of greater than this x value which you see here, you get all positive y values. So which means the function is positive, the value of the function is positive. When you take absolute value of positive value, you get the same positive value. So the graph is going to be same as shown here. Greater than this value of x, the graph is going to be same as the original graph. But when the original f of x, the value of y, turns negative for values of x behind or less than this x value shown here, the y values are negative. You see that the graph of the y values are going down the negative side here. But since we do the absolute value, these values also turn out to be positive, for which means for negative values of x beyond this intercept point, the entire graph is going to turn positive, which means it's going to be a reflection of the original graph. Whatever you see here, this is going to be reflected here along the x-axis. Along the x-axis, you see a reflection here. That's why the graph is looking like what you see here for absolute value of the entire function.